Okay, so in this video we're going to find the residues of this function here, 3z squared plus 1 over 3z squared minus 11z minus 4. So residues of f at blah blah blah, we don't know which, alpha such and such. Okay, so where do we start? Well, it looks like this may be factorable. So with a minus 4 and a 3, 3 4s are 12, just one gap here, so we can have minus 4 and minus 4 and plus 1. So what we could say, that 3z squared plus 1 over 3z, and then we've got a z, we're going to want the minus 4 over this side, 3 minus 4 is 12, and then a plus 1 on this side. Minus 4 times plus 1 minus 4, so that's that one taken care of. Okay, right, so now what are we going to do? So the next stage is maybe we could try something called the cover-up rule. So cover-up rule. Okay, now for this rule to be valid, what we need to do is to ensure that this is analytic everywhere. So we can say, as this is a polynomial function, f is analytic on complex plane. Okay, so that's taken care of. Now it'd be quite easy just to go straight in and say this one here, z equals a third, or sorry, z equals minus a third, cover that up and then plug it in. But we'd be mistaken there. What we need to do in the denominator, these when we're finding the zeros, we need them in the form of z plus or minus a number. Okay, now we've got this one's okay, z minus 4, no problem with that one. But this one here, the 3z plus 1. So we need to get that in the form of a single z. So then what we do is now we say that is also equal to 3z squared plus 1 over, now if we take the 3 out of this, we can bring it to the front, and then z plus 1 divided by 3, that's a third, and then the z minus 4, that stays. Okay, now we're ready to attack this residue theorem using the cover-up method. So to make this one disappear, we need z equals plus 4. So the residue, let's write it over here. Residue of f at plus 4. This is now going to disappear. So now what we do is we write 3z squared plus 1 over 3 times z plus a third. So that will then give us, plug in the value of plus 4, 3 times 4 squared plus 1 over 3 times 4 plus a third. Okay, let's work that out. 4 squared, 16, times 3, 48, plus 1, 49. 4 plus a third is 4 and a third, so that would be 12 over 3 plus 1 over 3, that's 13 over 3. That then gives us 39 over 3. Okay, so now what we've got, we can now say 39 over 3 times the top by 3, so that gives us 147 over 39. Divide that by 3, I think we can. So 3's into that go 49 over 13. Yeah, so therefore we can say the residue of f at plus 4 equals 49 over 13. Okay, so happy with that one. So now we need to find the residue of f for this one. So this time z equals a minus a third. So let's just box this off here. So the residue of f at minus a third equals, plug in minus a third for all these. So 3, well, let's just write out the z's first. 3z squared plus 1. I'm going to make this one disappear, but we still need the 3. So that's over 3z minus 4. That's why we take that out. Otherwise, as you can see, we're going to be by a factor of a third out from our correct answer. If we'd have left that in, we'd have covered that up. We'd have z minus 4. But now you can see we've now got 3z minus 4. So for minus a third, 3 times minus 1/3 squared plus 1 over 3 times minus 1/3 minus 4. Okay, minus a third squared, that's 1/9, times 3 is a third. So that's a third plus 1 over 3 minus a third minus a 4. So that's minus 13 over 3. Okay, third plus 1 is 4 over 3. Right, careful on this one. 3 times minus 13 over 3, well, that's just minus 13. Okay, now we can bring the 3 down to the bottom, and then that will give us, and with the minus out front as well, minus 4 over 39. So therefore we can say the residue of f, comma, minus 1/3 equals minus 4 over 39. Okay. That is the answers to our residues. Thanks for watching.